Welcome back to this series of videos on data engineering using Azure. In the last session, we ran a machine learning pipeline, taking our data from an external source, which means uploading the data from an external source into Azure Data Lake. Now we are going to deploy this as a production pipeline. So we mentioned in one of the earlier videos, one of the important things about model deployment or understanding the concept of model deployment is that usually when you work on the integrated development environment, like a Jupyter notebook or a Colab notebook or our studio, we assume that the developer and the user or the data engineer and the user are the same person. And hence the output is in the same environment as the input. But in reality, that is never the case. In reality, the user set is different and the developer set is different, and they need to be given totally different environments to work on, because while the developer is working on the model and trying to fine tune the model, the user may be working on another version of the model which has been published to the user. So what needs to be done is that we need to put this particular pipeline, which has already got trained, into a different model, a different environment. And once that is ported, uh, then a web app needs to be built, which will act as a front end to the user and will connect to this model in the different environment. And once the user puts the in on the web app, it will call this model that has been deployed in the production environment and you get the output. Okay, so we need to create the pipeline that is meant for the production purpose. This is called the inference pipeline. So here, if you go, you will see there's something called an inference pipeline, and there are two types of inference pipeline. One is called real-time inference pipeline, the other is batch inference pipeline. In real-time inference pipeline, the expectation is that as a user is putting the data one by one, the data flows into the model and predicts the output one by one. Whereas in case of a batch inference pipeline, the user may upload an Excel file or similar kind of data set as a batch, and then the system will give the output in batch. So we will create the real-time inference here. The moment we create a real-time inference, see what happens is it creates another draft experiment, draft pipeline, which is calling as diabetes prediction experiment real-time inference. So note that this is also a draft. Okay, these are draft. And you see some of the changes that have happened here. You can see that there is a web service output here, and there also should be a web service input, which will come over here. So usually most of these things are automated, but in some cases, some of these components may be missed out. So we'll actually put web service input. Web service input should be here. Now, why is this diabetes data set still there? Diabetes data set is still there to help of the schema of the data. What are the web service input and web service output doing? These are the entities that are going to interact with the app, which an app developer will make as a front end to the user. Okay, so this is the production pipeline. We have to submit this production pipeline as a job so that this is run. This production pipeline also has to run, and it has to be created as a job, and then only that job will be deployed in the production environment. Okay, so we will configure and submit. We can use the same experiment because the part of the same experiment, so called the experiment, yeah, the same. We'll take the same compute instance, then we'll submit. Job is submitted. Go to the job and see the another job, the name of the experiment. The experiment will have two jobs. This is a job. Latest job. And if you go here, there are two jobs. This one was the earlier job, which was completed, and this is the one which is running. Already this part is completed. We have discussed earlier that this is basically MD. This is the packaged uh, piece of code that will do the same transformation on the production data as was applied in the training and test data. No, this is the model actually. You can see here we have not done any transformation. That's why there's no transformation. This is just the model, which in this case is a logistic regression. In this case, the model is an equation. Okay. The same model is applied on this data. Now, obviously, there's no meaning of evaluating the data here. Actually, I should have deleted it because there's nothing to evaluate against. Okay, so this is the production environment. So you don't know what is the actual result. So whatever is the prediction that is been given by this model, that would be considered as the final result. So I should have actually deleted it, evaluate the result, but anyway, it's running. Let it run, and then you will uh, deploy it. Yep, it should have run. So once it has run, we are now ready to deploy. Now, this is the overall package. Now, what has happened is the entire set, which includes all the pre-processing, reading the data, pre-processing the data. Here, we don't have any pre-processing. Otherwise, there can be a pre-processing like normalization or cleaning missing values, etc. Same activities that were done during the model development stage, same activities will be done on the uh, data that has been provided as the input uh, through a packaged set of programs that is deployed on the production environment. It is like an executable file, which is doing the same set of functions on the input data as it was doing on the training data. That is deployed. And we've deployed it in a completely different environment, which is used purely for the production users and not used by the developers and is insulated from the developers. We'll go to deploy. So we will call the name of the deployment. Now, usually these days should be small letter. Usually these days, most of the companies will use Kubernetes services, which are basically Docker containers, orchestrated Docker containers, which can move small changes very rapidly from the developer environment to the production environment. So this is the agile method of deployment. Okay. This also called continuous integration, continuous deployment. So every time you make a small change, it is going to push that change um, very fast within the production environment. It's like having small ships moving from the dock to the main ship. So many times what happens, the main ship cannot come near the dock. Okay, so small ships will carry these changes of small containers to this big ship, and from the big ship will sail in the high sea. So similar kind of thing. So we'll use, but in this case, we are not going to use a Kubernetes service. Kubernetes service is not available in the student version. So we are going to use only the traditional container instance. Deploy. Once the deployment is complete, what we'll see is that we will see the model model getting deployed over here. Okay, so this is the model, which is basically a packaged file, a pickle file. Okay, it's like an executable file. Okay, and it contains all the codes that we developed and that we applied on the production data. And then the other one is something called endpoint. So endpoint means an environment where your final artifacts will be kept for use. So my final artifact is kept in the endpoint diabetes prediction. Now, when I build a web app, the web service is going to connect to this endpoint. Now, you can actually test if this endpoint is working fine or not. Now, since this is a student service, many times you will see that the deployment is unhealthy because the production environment is not sufficient to handle this workload. So you'll see it's unhealthy. But if you occasionally, sometimes if you're lucky, you'll see a healthy endpoint. In that case, you can also test the endpoint, okay, whether it's working or not. But here we can't test it because it's an unhealthy endpoint. It's not very common to get a healthy endpoint because the entire student account is not meant for any production purpose. So the kind of servers they allocate for these kind of jobs are pretty low end, and hence they may not be suitable for carrying this kind of work. Okay. So that's why in most of the cases you get an unhealthy. So we saw that when we take a data from the external environment, how we can actually deploy it into a production environment.